Dear students, in the last lecture we have seen that how to find Fourier series of the given function, okay, and how to determine the Fourier coefficient using Euler formula. Now let us continue our topic. So our next topic is Parseval's identity in the interval c to c plus 2 pi. So which is a very important identity in Fourier series. So let us see what is the Parseval's identity. Okay, Parseval's Parseval's identity. Identity. Parseval's identity. In the interval, your interval is given to you c to c plus 2 pi. This is the general interval. Okay. So we will state what is the Parseval's identity in this interval. The statement is there if f of x, f is any function, converges f of x converges uniformly in the interval c to c plus 2 pi, then Parseval's identity states that 1 upon 2 pi integration of limit c to c plus 2 pi function f of x the whole square dx, and this is equal to what? A naught square and plus 1 by 2 summation running from and sum running from 1 equal to n equal to 1 to infinity a n square plus bn square. Okay, so this identity is known as what? This identity is known as Parseval's identity. Parseval's identity. This identity is known as what? Parseval's identity for the function f of x in the interval c to c plus 2 pi. Okay, now there will be the several cases. If c is what? If c is 0, then your interval become 0 to 2 pi. If c is minus pi, then your interval become what? Minus pi to pi. So for different interval you will have the same identity, but what interval will change? Getting? You understood what is the Parseval's identity? Parseval's is the name of mathematician who is the very famous mathematician who derived this identity for Fourier series. Okay, that's why this identity is known as what? Parseval's identity. Now let us do some problem based on this. Should I do cases or leave this as it is? You know the cases, c is 0 and c is minus pi. Okay, your formula will be same, but limit will be changed. If c is 0, then you have interval 1 upon 2 pi integration of limit 0 to pi f of x the whole square dx, and this equal to a naught square plus 1 by 2 sum running from 1 to infinity a n square plus b n square. Okay, and the second case, if c is minus pi, then you will have formula 1 upon 2 pi integration of limit minus pi to pi and f of x the whole square dx, and equal to a naught square plus 1 by 2 sum running from 1 to infinity a n square plus b n square. Okay, I hope you will remember this formula. Okay, now let us do problem based on this so that you can understand what is the Parseval's identity. and why we are going to learn Parseval's identity. Okay, should I start problem? बोलिए बच्चों लोग, should I start problem?
Yes, sir.
हाँ सर।
हाँ चलिए, एग्जाम्पल example, obtain the Fourier series, obtain the Fourier series, Fourier series for the function f of x, okay, in the interval 0 to 2 pi, where your function is defined like this, where f of x is equal to x if if x is lies between 0 to pi, okay, and next function is 2 pi minus x when the function when x is lies between pi to 2 pi. This is open interval, pi to what? 2 pi. Your original interval is what? 0 to 2 pi, okay, but function split into two parts, so that your interval must split into two parts, okay. And after this, hence deduce that pi raised to 4 by deduce that pi raised to 4 by 96, and which is equal to what? 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4 and plus so on, okay. We will use Parseval's identity and deduce this deduction, okay. Here, when we will use Parseval's identity, when the power will be what? 4. When power will be 4, then we will use Parseval's identity. Why is this so? Because here function is in square form, so that we can use here Parseval's identity. This is the clue for using Parseval's identity. Getting? पार्सवाल्स आइडेंटिटी कभी यूज करने का, जब भी देखो ऐसा एक्सप्रेशन में पावर 4 रहेगा ना, तभी आपको पार्सवाल्स आइडेंटिटी यूज करना है, ठीक है, क्योंकि यहाँ देखो फंक्शन में क्या है, स्क्वायर फंक्शन है ना, यहाँ कोई फंक्शन रहेगा तो उसको इंटीग्रेट करोगे तो वो पावर उसका इंक्रीज हो जाएगा, इसलिए हम यहाँ पे ये क्लू है कि पावर जैसे 2 से ज़्यादा रहेगा तो फिर आप पार्सवाल्स आइडेंटिटी यहाँ पे यूज कर सकते हो, ठीक है। चलिए लेट अस डू द प्रॉब्लम सॉल्यूशन. What is our first step? Our first step is what? Let f of x equal to what? A naught plus sum running from n equal to 1 to infinity a n cos n x plus sum running from n equal to 1 to infinity b n sin n x, okay. Name this equation number star, okay. This is what require Fourier series. Just write down be a required Fourier series. Be a required Fourier series. Fourier series. Okay. Name this equation number what? Star. Name this equation number star. Now what? Now our job is what? To find the Fourier coefficients a naught, a n, and b n. Okay. Now to find Fourier coefficients a naught, a n, and b n. Okay. Let us find one by one. A naught. We know A naught is what? 1 upon 2 pi integration of limit 0 to what? 2 pi. Your interval is 0 to 2 pi. F of x and dx. This is your formula. Okay. And this equal to 1 upon 2 pi as it is. Okay. Your function is what? Split into two part. First function is this, second one is this. So for the first function, we will have limit 0 to pi. 0 to pi. F of x. F of x is this one. X and dx. Okay. And plus second function. Second function has limit pi to 2 pi. So write down pi to 2 pi. Okay. And f of x is what? This one. That is 2 pi minus x and write down dx. Chaliye, just integrate this. So let us move to the next page, then we will integrate it. Okay. So therefore we will have a naught equal to 1 upon 2 pi 1 upon 2 pi integration of limit 0 to pi integration of limit 0 to pi. Your function is ax dx and plus integration of limit pi to 2 pi. Your function is what? Your function is 2 pi minus ax dx. Okay. This is your function. Okay. Now what? Just integrate this. So this is equal to 1 upon 2 pi integrating this. So you will have ax square by 2. Okay. And providing limit 0 to pi and plus. So 2 pi is constant. I'm taking outside. So integration of dx is ax minus x square by 2. Okay. And providing limit pi to 2 pi. Just close the big bracket. So this equal to 1 upon 2 pi. Upper limit is what? Pi square by 2 and minus lower limit will be 0. Okay. Just put it here. And plus 2 pi upper limit. Instead of x, we putting here 2 pi. So 2 pi minus this will what? 4 pi square 2 pi the whole square, that is 4 pi square by 2. This is your what? Upper limit and minus lower limit. Instead of x we putting pi, so 2 pi into pi minus pi square by 2. Okay, just close the bracket. Now simplify. So this is 1 upon 2 pi. Okay, this is pi square by 2 and plus 2 to the 4 pi square minus 4 pi square by 2 and minus 2 pi square minus goes plus pi square by 2. Okay, just simplify this. This is 1 upon 2 pi your bracket. So this is what? Pi square by 2, pi square by 2, that is 2 pi square by 2. Okay, and plus cross multiply, that is 8 pi square minus 4 pi square by 2 minus 2 pi square. Simplify 1 upon 2 pi. Okay, this cancel. This is pi square and plus here you will get 4 pi square by 2 minus 2 pi square. Okay, and this equal to 1 upon 2 pi. Here you will have pi square plus 2 to the 4, that is 2 pi square minus 2 pi square. 2 pi square, 2 pi square gone. You will have 1 pi will cancel from this pi. So you will get pi by 2. you will get what? Pi by 2. So a naught is what? Pi by 2. Therefore, from this we'll write here a naught equal to what? Pi by 2. Okay, you got it? How to find a naught? Yes or no? Yes or no, students? Please tell me. You got it this much?
यस सर फर्स्ट पेज दिखाइए ना लिखने
हाँ, फर्स्ट ये वाला
यस सर
देख लिया.
यस सर
चलिए. Now, also we find an. an is what? Your an, you will have formula 1 upon pi integration of limit 0 to 2 pi 0 to 2 pi. Okay, and f of x cos nx dx. Okay, this is your formula. Let us move to the next page, then we will put the function. So therefore an equal to 1 upon pi as it is. Okay, your first function have limit 0 to pi, and f of x, your f of x is what? Your f of x is x, and cos n x dx. Okay, and plus second, your second limit have a second function has limit pi to 2 pi, pi to 2 pi. Your function is what? 2 pi minus x, or here will be what? Cos nx dx. Okay, just close the bracket. Now what? Our job is what? To integrate this. So this is equal to 1 upon pi. Okay, here we will use generalized integration by part. So this is x, first is u, second is b. X integration of v, that is what? Cos. Cos का integration, that is sine n x by n. Okay, minus derivative of this, that is 1. Okay, integration of this sine का integration cos n x by coefficient of n and coefficient of n, that is what? N square. Okay, so this is integration for first term, providing limit 0 to pi, and plus आ जाइए second पे. So u, this is u, this is b. So 2 pi minus x. Okay, our integration of cos is sine n x by n minus derivative of this. So this is constant 0, and derivative of this is minus 1, and integration of this. Integration of sine is minus cos n x by coefficient of cos, that is n, and n is already here, so n is square. Okay, now providing limit pi to 2 pi. Okay, just close the big bracket. So this equal to 1 upon pi. Before applying limit, just simplify the bracket first. X sine nx by n, minus minus goes plus cos nx by n square. Okay, providing limit 0 to pi, and plus 2 pi minus x sine nx by n, minus minus plus, and again minus cos nx by n square. Okay, and provide limit pi to 2 pi. Just close the big bracket. So this equal to 1 upon pi. Upper limit is pi. मैं यहाँ पे डायरेक्टली कर दूँ, बोलो कि स्टेप बाय स्टेप करूँ? यस और नो, प्लीज रिप्लाई.
सो स्टेप बाय स्टेप.
चले ठीक है, स्टेप बाय स्टेप करते हैं. इंस्टेड ऑफ एक्स पाई रखो, तो पाई ठीक है, just open the bracket pi. So instead of here, yes, sin n pi become 0, so we write here directly 0. ठीक है, you understood this? नहीं समझा आपको? Step by step. So this is what sin n pi, okay, sin n pi by n, and plus cos n pi by n square. Okay, this is upper limit minus lower limit. So यहाँ पे instead of x we putting here 0. So everything anything multiplied by 0 is 0, and plus cos 0 by n square. Okay, this is first term, and uh, we write here below second term, plus here 2 pi minus upper limit is 2 pi and sine 2 n pi by n minus cos 2 n pi by n square. Okay, minus lower limit is what? 2 pi minus pi. Okay, and into sine n pi by n minus cos n pi by n square. Okay, just close the bracket and simplify this first. 1 upon pi. Okay, sine multiple of pi is 0, so this is what? 0, and plus cos multiple of pi is what? Minus 1, so this is what? N term minus, so you write n raised to n. Okay, n raised to n by denominator term n square. Okay, and minus अंदर गया, cos 0 is 1, so this become 1 upon n square. Okay, and plus this is your first term, and plus 2 pi minus pi, this will 0, this will 0. Okay, and minus cos 2 n pi is 1, so this become 1 upon n square. Okay, and this is 2 minus 2 pi minus 1 is how much? Pi, but sine n pi is 0, so this will 0. Okay, minus minus goes plus. यहाँ पे cos n pi is what? Minus 1, but this is n term. Cos pi is minus 1, but this is n term, so we write minus 1 raised to n by n square. Okay, close the bracket. So this is 1 upon pi. Simplify this. So see here, this is minus 1 raised to n by n square, minus 1 raised to n by n square. So this is 2 times of minus 1 raised to n by n square, and minus, see here, minus 1 by n, minus 1 by n. So this is 2 times of n square. Okay, now we will take common. What is the common here? What is the 2 by n square is common, so we taking 2 by n square pi, and what is in bracket? Minus 1 raised to n minus 1. Okay, so this is what? This is your an. So therefore we write here an is what? An is 2 by n square pi minus 1 raised to n minus 1. Okay, now what? Our job is to find bn. Our job is what? To find bn. Let us move to the next page. Just write down the formula over here. Now we find bn, that is what? Bn equal to 1 by pi integration of limit 0 to 2 pi f of x sine nx dx, f of x sine nx dx. Okay, now let us move to the next page. So therefore bn is equal to 1 upon pi as it is. Okay, and split the integral into two parts. First one is limit running from 0 to pi, and function f of x is what? Function f of x is x, and write down sine n x plus. Second limit is to pi equation 2 pi minus x sine. Sine is there into sine n x, okay, and dx here dx, and so this is x. Integration of cos is what? Sine is what? Minus cos n x divided by what? N. Derivative of x 1, and derivative of x is 1. Integration of this minus sine n x by n square. N is already here. Coefficient of n, sine nx is n, or a can here n square. Okay, and just providing limit 0 to pi and plus second term. Again we will have same thing. So 2 pi minus x. Okay, integration of sine is minus cos n x by n. Okay, derivative of this, so this is minus 1. Okay, and integration of this, integration of minus cos is what? Minus sine n x by n square. Okay, just close the bracket, providing limit pi to 2 pi to 2 pi, just close the bracket. Okay, so this is equal to what? 1 upon pi, and just simplify, then apply the limit. This is minus ax cos n x by n, minus minus plus sine n x by n square, and providing limit 0 to pi, and plus 2 pi minus x, minus n is here. This is cos n x by n, minus minus plus, and minus sine n x by n square. Okay, and providing limit pi to 2 pi, just close the bracket. Okay, this is equal to 1 upon pi. Upper limit is what? Minus pi cos n pi by n, cos n pi by n, and plus sine n pi by n square. This is for upper limit. Okay, minus lower limit. So instead of x we putting 0, so this will 0, and plus sine 0 upon n square. Okay, this is for your first term, and plus second term. Second term is minus 2 pi minus 2 pi upper limit. Okay, and cos 2n pi by n, minus sine 2n pi by n square. Okay, this is for upper limit, and minus lower limit. Lower limit is what? Minus n is here, so just put this is in the bracket. So here we write minus sign, and put in the bracket. Everything is put in the bracket. Okay, so here will be what? Pi. So this is minus 2 pi minus pi, and cos n pi by n, and minus sine n pi by n square. Okay, okay, just close the bracket and this bracket. Okay, चलिए, now simplify So this is equal to 1 upon pi, and this is what? Minus pi. Cos n pi is what? Minus 1 raised to n by n, and plus sin n pi is 0. Okay, and minus and minus here. This will 0, and minus sin 0 is 0. This will 0. Okay, this is for first term, and plus second term. 2 pi minus 2 pi will what? 0, and minus sin 2n pi is 0. Okay, and minus and minus n here. 2 pi minus pi, that is pi. Cos n pi is what? Minus 1 raised to n by n, and sin n pi is 0. Okay, just close the brackets. So this is what? 1 upon pi minus pi minus 1 raised to n by n, minus minus goes here, plus pi minus 1 raised to n by n. This is the same thing. Wow, I think this will 0. So this will what? 0. Therefore bn equal to what? 0. वाह, कितना मजा आ गया, इतना बड़ा कैलकुलेशन एंड गिव्स 0. Interesting? Is this interesting or not?
So,
इंटरेस्ट
हाँ.
तो है, लेकिन लास्ट में जीरो आके पूरा मजा किरकिरा हो गया.
so,
हाँ हाँ हाँ,
so
बोलिए.
अपना cos n pi बोले तो pi पे अपना -1 आएगा ना, तो रेस टू n क्यों दिए उसमें?
बता रहा, देखो. कॉस कॉस देखो पाई कितना होता है, ठीक है. कॉस पाई कितना
-1
होता है? नहीं, कॉस पाई माइनस 1, ठीक है.
जी.
हाँ, अब फिर कॉस यहाँ पे 2 पाई रहेगा तो कितना आएगा?
1 आएगा.
1 आएगा, ठीक है. फिर कॉस में 3 पाई लिखूंगा तो क्या मिलेगा आपको? -1 आएगा, ठीक है.
हाँ
अगर कॉस 4 पाई लिख दिया तो क्या आएगा? +1 आएगा,
जी.
ठीक है. इसको मतलब क्या, ये रन हो रहा है ना, 1 2 3 4, कहाँ तक जा रहा है? अप टू n तक जा रहा है, ठीक है. n तक जा रहा है, और इसको अगर n की वैल्यू निकालूंगा तो यहाँ पे 1/n लिखूंगा. अभी n की वैल्यू अब रखते जाओ. n इक्वल टू 1 रहेगा तो -1, n इक्वल टू 2 रहेगा तो +1, n इक्वल टू n इक्वल टू 3 रहेगा तो -1 आएगा.
अच्छा सर.
समझ में? ये जनरल केस है.
जी सर.
गेटिंग? और साइन का मल्टीपल में पाई रहेगा तो हमेशा 0 रहता है, चाहे एक आए चाहे 2 आए चाहे कौन सा भी आए. नाउ अंडरस्टूड?
जी सर.
हाँ, let us move to the next page. Now substituting all the coefficient in equation number star. Substituting all the Fourier coefficients in equation number star, we get what? F of x equal to a naught. How much we found a naught? Pi by 2. A naught is pi by 2, and plus summation running from n equal to 1 to infinity an. How much found we an? An कितना आया? How much we found? 2 by n square pi, 2 by n square pi in bracket -1 raised to n minus 1 cos n x. यही था ना, देख लो जरा फिर से. So -1 raised to n -1 raised to 2 by n square pi -1 raised to n minus 1. Okay, same thing is there. Okay, and plus sum running from n equal to 1 to infinity. Your bn is 0, sin n x, matlab this will 0, and this can be written as what? F of x equal to pi by 2, and plus यहाँ पे देखिए 2/π कांस्टेंट है, जस्ट टेकिंग आउटसाइड 2/π and sum running from n equal to 1 to infinity. What is the remaining? So minus 1 raised to n minus 1, okay, by n square cos n x, and this will 0, no need to write. Okay, now what? Just run this series, just run your series. This is pi by 2 and plus 2/π. I am taking outside for n equal to 1. For n equal to 1, you will get what? Minus 1 and minus 1. That is what? Minus 2 by 1 square. Getting? If n is 2, so this is minus 1 square, that is plus 1 minus 1 0. ठीक है? So even के लिए क्या रहेगा? This series will be 0. And if n equal to 3, so this is minus 1 and minus 1 is what? Minus 2 times of, अब क्या, एक मिनट, cos भी आएगा ना, और this is what? Cos x, okay, minus 2 times of 3 square cos 3x minus 2 times of 5 square cos 5x and minus so on. Okay, for even case this series will be 0. So only odd term will survive. Okay, so this is what? Pi by 2 minus, see here minus 2 I'm taking outside from each term. Okay, so 2 here plus, and minus 2 I'm taking outside by pi. Just write down here. So this become cos x upon 1 square plus cos 3x upon 3 square and plus cos 5x upon 5 square and plus so on. Okay, this is infinite series. Here infinity, so this series run up to infinite many terms. So this is equal to what? Pi by 2 minus minus plus, that is, sorry, this is multiplication. So this become minus 2 to the 4. So this become minus 4 by pi and cos x upon 1 square plus cos 3x upon 3 square and plus cos 5x upon 5 square and plus so on. Okay, and plus so on. This is the required Fourier series, which is, just write down, which is a required Fourier series. Fourier series, okay, which is required Fourier series. यहाँ तक तो आपका कंप्लीट हो गया. Now deduction part. Deduction. Deduction part. Deduction में what have to do? Have to deduce by using this Fourier expansion. Okay, for this what have to do? Have to use Parseval's identity. Have to use Parseval's identity. Okay, for deduction we will use Parseval's identity. Okay, just write down. For deduction we shall use Parseval's identity. Parseval's identity. Okay, and what is the Parseval's identity? Just write down Parseval's identity in the interval 0 to 2 pi में. Okay, so just write down. So 1 upon 2 pi. Okay, 1 upon 2 pi integration of limit 0 to 2 pi, then f of x the whole square dx, and this is equal to what? This is equal to a naught square plus 1 by 2 summation running from n equal to 1 to infinity infinity a n square plus b n square. Okay, name this equation number double star. नेम दिस इक्वेशन नंबर व्हाट डबल स्टार, इसको मैंने डबल स्टार नाम दे दिया, ठीक है. बट आवर जॉब इज व्हाट, आवर जॉब इज फाइंड दिस लेफ्ट हैंड साइड. Okay, right hand side is already we found a naught, a n and b n we already found, just our job is what, to find left hand side. Okay, now we taking left hand side 1 upon 2 pi integration of limit 0 to 2 pi your function f of x the whole square and dx, and this equal to 1 upon 2 pi, okay, 0 to here. Now we split the function into two parts. First, first one is your limit running from 0 to pi, and f of x is what? Your f of x is x, but function is what? Is square. So this become what? Ax is square. Okay, and dx plus integration of limit pi to 2 pi f of x, but f of x is what? F of x the whole square. So you will get 2 pi minus x the whole square dx. I hope you understood this step. Yes. Kanojia, Abhishek. Are you
हाँ सर,
getting?
हाँ सर, हाँ सर।
समझ गए स्टेप? बहुत इंपॉर्टेंट स्टेप है. बच्चे लोग मिस्टेक यहाँ पे कहाँ पे करते हैं? यहाँ पे फंक्शन का स्क्वायर है तो क्या करते हैं, केवल फंक्शन ही लिखते हैं, तो यहाँ पे मिस्टेक हो जाता है. ठीक है, इसलिए मैं आपको यहाँ पे रिमाइंड करा रहा हूँ कि इस तरह से इसको लिखा जाता है. ठीक है. नाउ व्हाट, जस्ट इंटीग्रेट दिस. So 1 upon 2 pi integrate this is x cube by 3, okay, and 0 to pi, and plus how to integrate this, how to integrate this, what is the integration of this, integrate karo. So I'm integrating, okay, देखो, let us see how to integrate. So x, sorry, x नहीं, 2 pi minus x, okay, raised to what, raised to 3 by 3, but coefficient of x is what, -1. Okay, I think you understood. Pi to 2 pi, you understood how to integrate this, or just open this bracket then integrate each term. Okay, वो लेंदी हो जाएगा इसलिए मैंने ऐसा किया. देखते हैं सही आता है कि गलत आता है आंसर. ठीक है, just continue. So just providing limit, this is equal to 1 upon 2 pi, and your provide limit, upper limit, that is what, pi cube by 3, lower limit will be what, 0. Okay, minus 1 by 3 I'm taking outside. Okay, so yes, upper limit is what, 2 pi minus pi ka cube by no by is here, and minus 2 pi minus pi ka cube, no by term is 1 by 3, I'm taking up bar. Okay, just close the bracket. So I'm writing here. Are you able to see below? Yes. Are you able to see below? Yes or no?
हाँ सर।
दिखाई दे रहा है? चलो ठीक है. So this is what, 1 upon 2 pi, and this is pi q by 3 minus this term, देखो this term यहाँ पे 2 pi. Okay, this is upper limit 2 pi minus 2 pi, so this term will 0. Okay, minus here plus, so here you will get 1 pi q, that is pi q by 3. Okay, and simplify this, pi q by 3, pi q by 3, 2 times of pi q by 3, so 1 upon 2 pi into 2 times of pi q by 3, and 2 2 1 pi will cancel, so you will get pi square by 3. I think this is correct. Yes, absolutely correct. Okay, so please do not open this bracket. Do not open the bracket, just integrate this. Just but a thing is that you should divide by their coefficient. Your coefficient is -1. Okay, getting? If you opening this brackets, you will get complicated integration. Okay, so this is pi square by 3. Now what? Putting this value in equation number double star. Putting this value in equation double star. In equation double star, we get what we get? Pi square by 3. We found pi square by 3, na? Okay, pi square by 3. Okay, so this is equal to what? A naught square plus 1 by 2 summation running from n equal to 1 to infinity an square plus bn square. Okay, now name this equation number what? Triple star. Name this equation number triple star. Okay, now putting the value of a naught, an and bn in triple star. Putting the values of a naught, an and bn in equation triple star. Okay, we get pi square by 3. Okay, and this is a naught square. A naught square, how much we found the value of a naught? How much we found? A naught is pi by 2. Okay, so this become what? Pi by 2 ka whole square. Okay, no problem. And 1 by
5
2.
by 4.
Sum running from n equal to 1 to infinity. An, we found an. Where is that? An is this much. Okay, so I'm writing directly. This is 4. Just write down 2 by n square pi n square what? Pi square n square pi. अभी मैं उसका स्क्वायर बाद में लूँगा. n square pi -1 n -1 is to n and -1. Okay, and square of this term. Okay, square of this term and plus bn तो 0 है हमारा. नो प्रॉब्लम, इससे कुछ प्रॉब्लम नहीं है. So therefore pi square by 3 and this is equal to pi square by 4. Okay, and plus 1 by 2 summation running 1 to infinity. So this is what? This is 2 to the 4 n raised to 4 pi square and -1 raised to n -1 ka square. Okay, just run this series. So we will first simplify this, or just run this series then simplify. This is pi square by 3 and this is equal to what? Simplify karte chalo. So this is equal to pi square by 3 minus, I'm shifting this on that side. So pi square by 4 and pi square by 4 and this is equal to 1 by 2. Okay, just run this series. And 4 comes outside, so this is 4. Okay, 4 by pi square I'm taking outside. What will be the remaining term? Just write down one more step. Then this is n equal to 1 to infinity 4 by n raised to 4 pi square minus 1 raised to n minus 1 the whole square. Please don't forget to write the whole square, otherwise this will you will make mistake. Okay, just
Yes, sir.
simplify this. You simplifying this, so you will get what? Just take LCM. 4 3 is 12, so this is what? Simply pi square by 12. Okay, क्रॉस मल्टीप्लाई यहाँ 4, यहाँ पे 3, so 4 3 1 आएगा, so this is pi square by 12. Okay, and this equal to what? 4 by 2 pi square, 4 by 2 pi square, sum running from n equal to 1 to infinity, and just write down minus 1 raised to n minus 1 the whole square and by n raised to 4. अब run this series, either leave this as it is. So इसको क्या करेंगे, जरा सिंप्लीफाई कर लो. दिस इज पाई स्क्वायर बाय 12 एंड 2 से 2, सो दिस विल गो, ए ऊपर जाएगा. नेक्स्ट स्टेप में 2 बाय पाई स्क्वायर and sum running from n equal to 1 to infinity minus 1 raised to n minus 1 the whole square by n raised to 4. a उधर गया, so this become what? Pi raised to 4 and what? Pi raised to 4 something mistake. यहाँ पे a नीचे आएगा तो कितना आएगा? 24. ओके, 24. अभी तो इसमें से भी बाकी है ना. So this equal to summation running from n equal to 1 to infinity minus 1 raised to n minus 1 to the power 2 divided by n raised to 4. Now run this series. Okay, we are going to run. Okay, यहाँ पे n equal to 1 डालेंगे तो क्या मिलेगा आपको? n equal to 1, so this is what? minus 1 that is minus 2 और 2 इधर. हाउ मच दिस?
सर इसके बाद हम लोग कर लेंगे, अभी टाइम हो गया सर.
टाइम हो गया. ओके,
यस सर,
हाउ मच
5 मिनट
टाइम?
हो गए.
5 मिनट ज़्यादा हो गया.
हाँ सर.
मतलब पूरे लेक्चर में एक ही प्रॉब्लम. ओके ठीक है, इसके बाद आप कर लेना. ठीक है, को डिडक्शन पार्ट आपका दो स्टेप में आएगा. ठीक है,
सर वो भी कंप्लीट नहीं हुआ है.
हाँ
पूरे लेक्चर में प्रॉब्लम, लेकिन वो भी कंप्लीट नहीं हुआ है.
हाँ, वो भी कंप्लीट नहीं हुआ. 1 घंटे में आपका एक ही प्रॉब्लम हुआ, वो भी कंप्लीट नहीं हो पाया.
सर वो एंड वाला हम लोग कर लेंगे फिर.
ठीक है, आप देख
कल
लीजिए यहाँ.
डिस्कस करते हैं.
हाँ, कहीं से मिस्टेक होगा तो भी इसको डिराइव करके देख लेना. ठीक है, क्योंकि ये लास्ट पार्ट है. आपका प्रोसीजर यही है, इसी तरह से किया जाता है. अगर मेरे पास टाइम रहेगा तो मैं इसको अभी करके अपलोड कर दूंगा, नहीं तो फिर आप लोग कर लेना. ठीक है.
ओके सर.
Thank you all of you for joining to us, and we will meet soon in the next lecture. Now you can leave this meeting.
Thank you, sir.
Thank
Thank
you.